This is the second lecture on ECG basics, and before learning how to read the ECG, we need to know some notes about ECG paper calibration, and this for better understanding. At start, I want you to remember that some physics to understand how to transform the distance measured on the ECG on the horizontal axis into time. First, note that the ECG paper gets out of the ECG machine at a constant speed. That speed is 25 millimeter per second. And remembering that from physics, that speed equal distance divided by time. And here we have the pre-calibrated speed to be constant at 25 millimeter per second. And we can measure horizontally the distance on the ECG paper, so we can get the time easily. So the measured distance on the ECG paper now can be transformed easily to time. So if you are having here time equaling measured distance divided by speed, and we know that speed is 25 millimeter per second. So as an example, if you measured 25 millimeter horizontal on the ECG paper, this will equal 25 divided by 25 equaling 1 second. And for each 5 millimeter measured on the ECG paper, it will equal 5 divided by 25 equaling 1/5 of seconds, that is 0.2 seconds, that is 200 milliseconds. And for 1 millimeter measured on the ECG paper, it will equal 1 divided by 25, so it will equal 0.04 second equaling 40 milliseconds. So that for each 25 millimeter measured horizontally on the ECG paper, that will equal 1 second, and that 1 second is 1000 milliseconds. And for each 5 millimeter measured horizontally on the ECG paper, that will equal 0.2 second, that's equaling 200 milliseconds. And for each 1 millimeter measured horizontally on the ECG paper, that will equal 0.04 seconds, that is 40 milliseconds. But how horizontal distance to be measured on the ECG paper? Previously, in old days, ECG paper was not pre-calibrated as today, and the cardiologist has to use a ruler for measuring the distance on the recorded ECG, and then to transform this measured distance into time. The ruler on one side, as you see, having distance, and on the other side is for time. That for each 5 millimeter is 0.2 seconds. Currently, knowing that the ECG paper velocity move out of the machine at constant speed of 25 millimeter per second, the ECG paper now is pre-calibrated. That small box each equaling 5 millimeter horizontally width, and that will equal 0.2 second in time, that is 200 milliseconds. But 200 milliseconds is too much time regarding intervals on the cardiac cycle. So each small box is further divided into 5 minute boxes. Each is 1 millimeter width, and each minute box will equal 40 milliseconds. So that it's the horizontal axis that represents the time here. What about the vertical axis in the ECG paper? It represents the amplitude. And also here you will notice that each box is 5 millimeter in amplitude, and it is equaling 0.5 millivolt, and each 10 millimeter on the vertical axis would represent 1 millivolt. So it is easier now. You will not use a ruler to measure the distance. You will just count the boxes horizontally. Each large box, as you see, is 200 milliseconds, and each minute box is 40 milliseconds. Each large box is 5 millimeter width, and each minute box is 1 millimeter width. So as an example, on the right side here, if I told you that P wave is the atrial depolarization and the QRS is the ventricular depolarization, and that the interval from the start of the P wave to the start of the QRS is 4 minute squares, and each minute square is 40 milliseconds, so that the BR interval will be equaling 4 multiplied by 40, so it is 160 milliseconds. So the BR interval would be 160 milliseconds. This BR interval represents the atrioventricular delay, AV delay. Okay? And if I told you that the QRS duration is 3 minute squares, like you see here, and each minute square, as you know, is now 40 milliseconds. So the QRS duration is 3 multiplied by 40, and the QRS duration is 120 milliseconds. The QRS represents the ventricular depolarization. So this QRS is duration can be measured easily and representing the ventricular depolarization. And I hope it was easy, and next lecture inshallah we'll have more discussion about the cardiac intervals. Thank you.